I'm on page 92 of the exercise book, and we are looking at question 5. And it tells me that all the questions on this page refer to this story. In a shopping mall, the gummy charges $1 per pound for gummy bears and $1.25 for a container. The bear charges $2 a pound, but only 50 cents for a container for gummy bears. Let X be the number of pounds and Y be the total cost. And before I do anything else, I'm going to get an idea of what the graph should look like. The independent variable, the thing that you choose, is the number of pounds. And then the cost is going to be the Y variable. I remember once when I was a kid, my family went to Cape Canaveral in Florida, and I love those Jelly Belly jelly beans. So I bought like 5 pounds of those jelly beans because at the time they didn't have them here where I live. So I put the bag of jelly beans in the trunk of the car. We were almost in Miami, Florida in July, so you can imagine what they looked like when I came out. I never read this problem that I don't remember the jelly beans. Okay, so I'm looking for a function of cost to pounds. And here comes the actual equations. So here's in simple terms what or I won't say simple terms, I'll say in word form what I'm doing. I'm going to take the slope and I'm going to multiply that by the number of pounds. And then I'm going to add the fee for the container. So for the gummy, we have Y equals $1 per pound plus the $1.25 for a container. So you could go in and just buy a container with no jelly beans or no gummy bears, and you would still pay $1.25. So the 0, 0 test on this one is not met. Y equals 1x plus 125. And remember, in the algebra books, they will drop the ghost 1. So x plus $1.25 is going to be the gummy charge. That's this one. Then the cost at the bear is $2 a pound plus 50 cents for the container. So that would be the other equation. And that's what they wanted me to find. So I like answer D, as in dog. Okay, number 6. This is one I moved to my notebook because I need a little bit more space. Oh, I need to get the, oh no, I just closed out my file where it's homework odds. Are we on an odd page or an even page? I can't remember. And that's the wrong homework. That's for the next chapter. Here we go. Sorry, guys. I hit the X to close out the chapter. And we are on an even page, so I didn't even need that. Here we go. I need to get the equations that we wrote down. So let me copy that and bring that over as well. All right. So let's take a look here at number 6. Now that we have these equations that we wrote. And let me get rid of the parts that we don't need. All right, it says, which description of the solution is not true? Now you might be thinking, what solution? What are they talking about? Well, that's what we have to work for. We have to get a solution for this system that we just wrote. So I'm going to do that by graphing. Okay? Now let's extend what we know here. For this one, we know that the slope is positive 1 and that the y-intercept is 0, 1.25. For this one, the slope is 2 and the y-intercept is 0, 50 cents, or 0.5, I'll say, or let's say 0.50. We'll scale it that way. Okay, so I'm going to draw a graph. And I said the 0, 0 principle is not met here, but we can still just use first quadrant because we're talking about a cost function. So let's draw the grid. I need to get it straight. I am just using the first quadrant, but you can draw the whole plane if you want to. And remember what this looked like. Cost over pounds. So cost in dollars over pounds. And for pounds, I'm just going to use a scale of 1. So I have 1, 2, 3, 4, 5, 6. And then for the cost, I'm going to scale it in terms of quarters. So we have $0, and there's 25 cents, 50 cents, 75 cents, $1. Then $1.25, $1.50, $1.75, $2. $2.25, $2.50, $2.75, $3. And then there's $3.50. So that is my cost dependent variable. So starting with the blue function, I believe that was called the gummy, I'm going to start at 0, $1.25. Because when you go in there and you buy the container, you pay $1.25. That's the flat fee. At the other store, you only pay 50 cents. So you can see that the starting points for these two stores are different, but they do not satisfy the 0, 0 principle. Okay, for the gummy, the slope is 1, so that means it's up 1, run 1, rise 1, run 1, rise 1, run 1. So let's go ahead, and I shouldn't have scaled it the way I did I? Okay, how do I want to explain this? I was going to use rise over run, but I don't think that's the best option. Let's go ahead and do some substituting and get the at least 2 more points. So for the gummy, we have y equals x plus $1.25. So when you buy 1 pound of gummy bears, your total cost is going to be $2.25. Let's go ahead and graph that. So 1, 2.25. So 1 and then $2.25. Let's do one more for this store. So when y is 2 pounds, when x is 2 pounds, y is $3.25. So 2 is all the way up to $3.25. So let's go ahead and graph this equation or this function. You can use either term in this case. That's pretty good. I'll just go ahead and leave that one there. And that one is representing the gummy. That is the blue line, the blue highlighted line. Okay, let's do the other store, which is called the Bear, and we have 2x plus 50 cents. So when you just buy 1 pound, it will cost you $2.50. So on this line, we have over 1 up to 250, which is right here. All right, if you buy another pound, so when x is 2, y is 4 plus the container fee is $4.50. I can't even get this on my graph, but that's okay. It's still worth looking at. So the graph for this one is going to look something like that. And that is your yellow line. What I am looking for is where those two intersect. Where do they come together? And that's going to be right here. So the solution to this equation is where that intersection occurs. It is about 75 a quarter, 3/4 of a pound for $2. So that would be the solution to this system, because the solution to a system is always a point. All right, now let's look at our choices. Which description of the solution is not true? The lines intersect, so there is one solution. That is true. We can see it right there in the black point. The bear's linear relationship has a steeper slope than the gummies. The bear's is what I've highlighted in yellow, and the gummies I've highlighted in blue. So the yellow line is steeper than the blue line, and that is true. They both charge the same amount for 3/4 of a pound. That is true. That's where the intersection is occurring. They both charge $2 at that point. The gummy, which is the yellow, charges a less expensive initial fee for the gummies than the bear does. Well, that's saying that the gummy, which charges, wait a minute, I've got those backwards. The gummy is $1. Let me do it this way. Let's look at the actual y-intercepts for these. The gummy is the $1.25, is less than 50 cents. Is that true? No, that is not true. You get the same amount of gummy bears at both places when you spend $2. So what that's saying is when y is 2, what is x at both places? And that is a true statement, because at both places it's 75 hundredths of a pound. So it's 3/4 of a pound. That statement is true. So the one that is not true is D. And when they're talking about the initial fee, they're talking about the container fee. I like that question, partially because I like gummy bears, but it's a good question too. All right, back to the page. And let me mark number 6, and then we'll look at number 7. I believe that I had that one on my notebook as well. So let me go back and we'll take a look. Which statement is not true? Let me bring in my equations again, because I am not going to trust that I remember them. If you can remember them, that is wonderful. But I don't trust my brain. It's crammed too full of math. And let me just go back and be sure. Give me 1 second. The gummy was first. Okay, so this is the gummy. And I think that's why they chose these names, because they're in order: gummy bear. So you can sort of keep them straight. The gummies are more expensive than the bears per pound. I will eventually get this how I want it. I want to help you learn to write these math statements. So the gummy is $1 a pound, and that's saying that that is more than $2 a pound. That is a false statement. So that's looking like the answer. The bear charges $3.50 for 1.5 pounds of gummies. Well, the bear's formula is y equals 2x plus 50 cents. When x is 1.5, so we are going to multiply 2 times 1.5. Sure I am. There's that calculator. It gets away from me. So 2 times 1.5 is 3. Plus 50 cents. $3.50 for 1.5 pounds. That is a true statement. The bear charges $1 more than the gummy for 1 3/4 pounds of gummies. So let's go ahead and do the bear. We've got it right here. And we're going to let x be 1 3/4. So 1.75. And then we have to add on the container fee. So y equals 2 times 1.75. That's $3.50. Plus 50 means at the bear you would pay $4 for that amount. So let's do the other equation, which is y equals x plus 125. Now remember, this is the bear, and this is the gummy. So we have y equals 1.75 plus 1.25, and that is going to be $3. So the bear is $1 more than the gummy. That is true. The gummy charges 50 cents more than the bear for 1/4 a pound of gummies. So y equals x plus 125. I'm putting gummy first because the option D puts gummy first. So we have 1/4 a pound plus, so we would have $1.50 at gummy. And then at bear, we need the other equation. And so we would have 2 times 1/4 a pound plus 50 cents. So 2 times a quarter is going to be 50 cents plus 50 cents. And that will be $1. The gummy charges 50 cents more than the bear. That is true. You see why I needed notebook paper to do this one. And finally, we have option E. The gummy charges $2.25 less than the bear for 3 pounds of gummies. So y equals x plus 125. And we're going to use x of 3 plus 125. That's 425. And then we do the same 3 pounds on the other formula. So 2 times 3 plus 50 cents. That is 6 plus 50 is 650. And then we have to subtract those. 650 minus 425 is 225. So that is also a true statement. The one that is not a true statement is the one we want, and that was A this time. Usually it'll be the last one, but on this one it was the one right out of the gate. So number 7 is A. Number 8. Which graph represents the solution to the system? Now remember what the solution was. So let's go back to our graph. The solution is that black point right there. So I'm just going to copy this. We'll need that to figure out which one of these graphs is going to fit. So I need to take out that big blue line and just keep my solution. So the first thing I'm going to check is the setup of the graph. We need dollars over pounds, and that is the case in all of them. So that condition is met. They're graphed correctly. The next thing I want to look at is the scale. So they all appear to have the same scale. That's not going to help me. So we're actually looking for this point because the solution to a system is a point. So the graph that has that point is the graph I'm looking for. 75, this is 3/4 of a pound. 75 hundredths. That's the same as 3/4 a pound. Costs $2. Okay, here we go. Look at that. 3/4 of a pound. That would be right here. $2. That intersection. I like that one. This is saying 3/4 of a pound costs $2. This one is saying 3/4 of a pound costs $2. This one is saying that 1.75, so 1 3/4 pounds costs $2. We can rule that one out. That's the wrong point. So that's not it. Look at this one. There's the intersection. And this is saying that just under 1 1/4 pounds. I'm just going to round it because this is not the answer, but we still need to plot it. Is $4. This one, they don't actually touch, but they would if they kept going right there. So this one is saying that 2 and 2.25 pounds cost $3. All right. So we can eliminate C, D, and E. The points do not match. So I can get rid of C, of D, and of E. So we are left with these two. The points match here. Nothing wrong with that. The graphs match. The scale is fine. So how in the world am I going to know? What's the difference between these two graphs? This one has a positive slope, which is saying essentially the more pounds you buy, the more dollars you pay. This one is having a negative slope, which is saying the more pounds you buy, the less dollars you pay. So which scenario is the case? Well, you can use just common reasoning, or you can look at your equations that you wrote. Goodness, I don't want to do that because that took away everything. Your slopes are M is positive 1 and Y is positive 2. Excuse me. M is positive 2. So the slopes for both equations are positive. And for that reason, I would select A on this one. That is a very good question. But all those go together. If you miss the equations in number 5, then the whole thing is going to be skewed. So it's really important to get each step right.